Hello everyone, this is Geometry Unit 3, Lesson 4, Isosceles triangles. Let's get started here. A little bit of vocabulary regarding the isosceles triangle. What you'll notice in an isosceles triangle is that you have two legs, and these legs are sides of the triangle that have the same measure. You can see here with the markings, these two sides have the same length. The base is the side length that's not equal in measure to the other two. Okay, now in an isosceles triangle, the base angles are congruent. So the angles across from the congruent sides are equal in measure. Those are called the base angles. And the vertex angle is the angle not equal to the base angles. So really it's kind of interesting that the legs are across from the base angles that are congruent, hence the legs are congruent as well. And the base itself, right, in purple here, this length actually sketched in red, is across from the angle that's not equal to the base angles. So it's an interesting relationship, and you can kind of see the symmetry within it. Let's talk a little bit more through an example using an isosceles triangle. All right, here we are. We got a couple of isosceles triangles. I've got my vertex right here. This is my vertex angle. Okay, there you have it, right there, 34 degrees. I've got my legs here. You can see marked congruent. Therefore, my base angles are located here along the base. Here's our base length. And so in blue, let's put them in blue, here are our base angles. Well, what we know about base angles is that they're congruent in measure. So both would be considered x degrees. Now in a triangle, using the triangle sum conjecture, I can say that x plus the vertex angle of 34 should equal 180 degrees. I'm going to subtract 180 degrees, and I'm going to combine x plus x to be 2x. So if I subtract 34 from 180, I get 120, nope, that's incorrect. I get 146 degrees. When I divide by 2, it looks like x would be 73 degrees. Okay, you can always go back and check, is 73 plus 73 plus 34 equal to 180? Use your calculator and solve. Okay, likewise, let's look at number 2 here. Here's my vertex angle. Vertex angle is located between the two legs. Okay, that makes this length over here in red, my base. And that makes these two angles my base angles. And of course, two base angles in an isosceles triangle have equal measure. So to find x, I'm going to take x plus 64 plus 64, set it equal to 180 using the triangle sum conjecture. That means x plus 128 is equal to 180. Okay, so we subtract, and we will get, it looks like 52 degrees for x. Again, you can confirm using the triangle sum conjecture, 64, 64, and 52 add up to 180. All right, let's continue. All right, 3 more examples here. In the first example, it looks like I'm given the vertex angle. Here is the vertex angle of 24 degrees. This letter is Z, I believe. So base angles would be congruent, meaning that these two angles here would be congruent. So 2Z plus 24 adds to 180. Triangle sum conjecture right there. So 2Z, I always cross my Z's so I don't mistake them for 2's, would be 156. I'm going to divide. That'd be 78 degrees. So Z equals 78 degrees. Interesting example here in example number 2, or the second example. Anytime I'm presenting a question, I would highly suggest that you try it, pause the video, try it, come back, see how your work went. Our vertex angle here is y. Okay, and our base angles are 50 and x. So I know immediately that x will equal 50 degrees because base angles in an isosceles triangle are congruent. So I'm going to use the triangle inequality, the triangle sum conjecture. I'm getting ahead of myself. 50 plus y equals 180. Well, that's 100 plus y equals 180, so y should equal 80. There you go. That's definitely not to scale. That triangle probably should have looked more like this, where that's 50, and then this could be 80. All right, awesome. Let's look at the third example on this page. We're actually asked here, new to us, previous to our prior examples, but we're asked to find a side length. That side length being A. Well, in an isosceles triangle, the legs are congruent. Therefore, A should be 5 centimeters. Now, within the context of this question, 100 is our vertex angle. Therefore, the base angles will be congruent in measure. So I'm going to call this angle right here B as well. So 100 plus 2B's is equal to 180. That means that 2B is equal to 80. Thus, B should equal 40. That triangle there looks a little bit more to scale than the previous one. All right, let's continue with some more examples. All right, we come here to the converse of the isosceles triangle conjecture. And this is also true. So if the base angles of a triangle are congruent, then the triangle is isosceles. So before we said that if a triangle is isosceles, then its base angles are congruent. Now we're flipping that around. This is called the converse. If the base angles of a triangle are congruent, then the triangle is isosceles. So as I look at this example down here, I can see that I've got base angles congruent. What that tells me is this is an isosceles triangle. Therefore, these sides right here are the legs, and y is the vertex angle. So now I can work with what I know, and I can say that x is a leg, which should be equal to the other leg, which is 10 centimeters. Likewise, y, with regards to the triangle sum conjecture, 71 plus 71 plus y should equal 180 degrees. That's 142 plus y equals 180. That leaves us, if we subtract accurately, with 38 degrees for y. Okay, let's move on and look at a couple more examples. Okay, 2 more examples here. I'm actually going to use a shortcut called the exterior angle sum conjecture that we talked about in lesson, I believe it was lesson 3, maybe lesson 2, can't remember at this point. But that told me that the exterior angle is going to be equal to the sum of the remote interior angles. And I've marked those base angles congruent, seeing that this is an isosceles triangle. So again, that exterior angles sum conjecture allows me to say, switch back to pen, not to highlighter there, that 145 degrees is equal to A plus A. All right, so interestingly enough, I can do this question in a slightly different manner. I'm first going to solve. Divide by 2, I get 72.5. Now, if you don't remember the exterior angle sum conjecture, and that just doesn't jump off the page at you, what you can do is find the vertex angle. So if this angle is 145, then the vertex angle would have to be, what would that be, 35. And then what you know is that 35 plus A is equal to 180. When you subtract, I'm going to combine the A's to be 2A. When you subtract, you just end up getting the same expression that we did above. So the exterior angles sum conjecture is very, very helpful, right? I can skip right to this point if I recognize it. Okay, one more example here, and then we'll call it good for these notes. I've got triangle ABC, and I know that the triangle's perimeter is 25. So if the perimeter is 25, that means that AB plus BC plus AC, those are all side lengths, measurements of the side lengths, should be 25 centimeters. Well, I know that this is an isosceles triangle, right? I see the markings. Therefore, I can say that BC is also 9 centimeters. So I know AB is 9. I know BC is 9. I don't know AC's measure. So I'm going to add 9 and 9, which is 18. And I'm going to subtract 18 from 25, and I get 7. So that tells me that this base side, right, will be 7 centimeters, which makes sense in the context of an isosceles triangle, right? The legs are the same, and typically the base is different. If the base was the same as the legs, we'd call that equilateral. All right, so we know AC is 7 centimeters. Let's look at the measure of angle C. I'm going to call this measure X. I'm going to call this measure X. Seeing that I'm dealing with an isosceles triangle here, I know using the triangle sum conjecture, I can say that X plus 38 is equal to 180. Therefore, if I subtract 38 from both sides, I get 142. I believe 142. Therefore, X should equal 71. Since I have defined C, the measure of angle C, as X, I can say that the measure of angle C is equal to 71. All right, guys, that's it for lesson 4. I hope it went well. We'll see you in the next video.